in our review of statistical inference for two populations. A transportation agency would like to compare the average amount of time it takes passengers to pass through airport security at two locations during peak times. The following table summarizes in minutes the results of two random samples from each airport. So we want to perform a hypothesis test using significance level alpha equal 0.01 to determine if the average time to pass through security in location 1 is more than the average time to pass through security in location 2. So we're going, in this case, to assume that population variances for time through security of these two locations are equal. So we're going to be doing a pooled test, equal variances. So here, we're arguing that we're trying to argue that the mean time for location 1 is greater, so the null hypothesis would be less than or equal to, and our alternative, what we're trying to show, would be that it's greater than. So if you think about putting the mu2 on the other side, that would be mu1 is greater than mu2. So we're going to do a two-sample t-test in this case because we have sample standard deviations for both samples. We do not know the population standard deviation. So over here in StatCrunch stat, we're going to run t-test, a two-sample t-test with the summary data. So from our summary data, we're going to use the sample mean for location 1 of 14.5, a sample standard deviation of 5.6, from a sample of 23. Our sample 2, location 2, we had a sample mean of 11.5, a sample standard deviation of 4.6, and a sample size of 27. We're assuming equal variances, so we're going to do a pooled variance test. Okay, our hypotheses would be that the difference is 0, and we're trying to argue that it's greater than 0. So now we're going to run our test. And so in our table, we have output, and in this case, our t statistic turns out to be rounded to 2 decimal places, 2.08. So typing in 2.08 with a p-value rounded to 3 decimal places of 0.021. Like that 1. Okay. So remember our significance level, alpha, was going to be 0.01. And so in this case, our p-value is greater than the significance level. So for this test, using their significance level, we would fail to reject. So if we interpret our results, right, since the p-value, right, is not less than the significance level, do not reject the null hypothesis. So that would be our choice based upon the significance level of 0.01. So here it asks, what assumptions need to be made in order to perform this procedure? So remember, when you're doing a t-test, one sample or two sample, you need to make sure that the sample means behave like normal random variables. And there's two ways that we can achieve this. One is if the population is normally distributed in each case, and the other is if the sample sizes are larger than 30 or are large enough that we can apply the central limit theorem, then we could assume that the sample means, the x bar values, behave like normal random variables. In this case, the samples are too small to apply the central limit theorem, so we must assume that the populations from which we're sampling, both in location 1 and location 2, are normally distributed. So in this case, it must be assumed that the distribution for both populations are normally distributed and that the samples are independent samples. So those are the two things that we need: independent samples, and we need the normality for the sample means. And we achieve the normality here, because our small samples, by assuming the populations are normally distributed. I hope this helps.